Hey, Minecraft! Daifuku here. Chests. In Minecraft, we use them to store items we gathered from our adventures. They came in many sizes, big and small. I love them all. But what if they are full? You see, just like in our daily lives, storage must be organized for maximum capacity. So for this project, our focus will be on showing an optimum way to sort and organize item stacks in Minecraft, visualized by using the help of Python. We will be utilizing two sorting algorithms, which are bucket sort for categorizing and quick sort for sorting items in orders.
Like any storage in real life, Minecraft chests can contain items and objects. Not only that, we can also take things from it and even organize it for easier access. In Minecraft, there are many varieties of items. Some of them can be compacted to stacks of 64, 16, while others can't be stacked at all. There are many ways to sort a chest in Minecraft. This time, we'll be sorting alphabetically from A to Z, and by the amount, either descending or ascending. As you can see in this chest right here, the items are scattered randomly in an unstacked and unsorted manner. If we were to sort this alphabetically, the chest would look something like this. From top to bottom, left to right, it would be apple, bone, cake, dirt, egg, gold, and oak sapling, and by the amount in either descending or ascending order. For the sake of simplicity, we'll assume that all items can stack up to 64, and the name of the items will be represented in a single alphabet letter in the display grid that will make up for this project.
So in this project, we will be implementing three functions. First is add function to add items to the chest. Second is take to take items from the chest. Last one, which is combine unstacked items to compact item into a stack of 64. For simplicity, in the result demonstration, we will show the chest interface using tablet package in Python. And what is tablet? The tablet library provides a command line utility to help you display tables directly from the command line or terminal. At first, we have planned to use tkinter to show interface of our result. But the reason why we use this tablet library is to simulate the table inventory in Minecraft, and also it can run on Google Colab and show in the command line instead.
Now, we will walk you through the quick sort function, a key part of a Minecraft chest sorting algorithm. This function is responsible for organizing items, either by letter or by numbers, making sure everything is perfectly ordered within your chest. Let's break it down step by step. When you call the quick sort function, you pass in an array of elements. Each element has two parts, a letter like A and a numeric value like 5. There's also a sort letter flag that decides how we want to sort these items. If sort letter is set to true, we will sort the letters. If not, we will sort by the numbers. Now, we've come to the core of quick sort. If the array that we pass in has 1 or 0 items, we will simply return it. There's no sorting needed. But if it has more than 1 item, here's where the real magic happens. We start by selecting a pivot element, which is simply the item in the middle of the list. Then, we compare every other item in the array to the pivot. There are 3 possible outcomes. If an item is less than the pivot, it goes into the left list. If it's greater than the pivot, it goes into the right list. And if it's equal to the pivot, it stays in the middle list. Next, the bucket sort will create an empty dictionary. This dictionary will store keys value pairs as A to Z for being used to categorize the elements. The function will loop through the given array and store each element into each category's letters. And quick sort is called to sort everything in each category. Once it has sorted all categories, all the values of every key will be combined into one list. And that's how we get a completely sorted array for our chest.
We define a function called linear search by letter that takes two inputs, which is elements and target letter. After that, we declare the list name result. This is the list contain all the items that started with the target letter along with their positions. Next, we set the loop count at 0. So we get into the while loop. We run as long as loop count is less than the range of the list to ensure that we check every single item in the list. Inside the loop, we check if the first letter of the item equals the letter we are looking for. If it matches, add the element and its index to the result list. After that, increase loop count by 1 after each iteration to check the next item in the list. Once loop has finished, we return the result list.
Let's break down what this function does in the context of a Minecraft chest sorting algorithm. The function is called add, and it takes two arguments, target letter and amount. It starts by declaring a few variables and retrieving the current state of the chest, represented by the global elements array. The chest is defined as having 3 rows and 9 columns, meaning there are 27 total slots available. Next, it searches for the items in the chest that match the target letter using a helper function, the linear search by letter. Then, it calculates how many empty cells are left by subtracting the number of filled slots from the total. The allowedMount variable will store how many of this item you can fit into the chest, starting by summing up the free space in the stacks of matching items already in the chest. After that, the algorithm checks whether the amount we're trying to add exceeds the available space. If it does, it stops and prints an error message, letting us know that we don't have enough room. If the amount fits, the function moves to the next phase, clearing out the matching items and recalculating the total amount including the current stack sizes. Then, it proceeds to break down the total amount into stacks of 64, which is Minecraft's maximum stack size for most items. Once the stacks are prepared, any remaining amount is added back as a new stack. Finally, it sorts all the items using a bucket sort function and displays the chest grid after the changes. In short, this function efficiently handles adding items into a chest, checking for available space, and reorganizing the chest to keep it sorted.
Now this next function is called take. It helps us manage items inside the chest by finding a specific type, pulling out the amount we need, and making sure everything stays neat and organized. The first thing this function does is tap into the global list of items inside the chest. We're calling it elements. Think of it as checking what's inside the chest. Next, it searches the chest for a specific item, like say B for blocks of birch wood. The linear search by letter function digs through the chest and returns a list of all matching items. Once we know what matches, the function loops through these items to see how much is available. For example, if you had 2 stacks of birch wood, 32 in one stack and 48 in another, the function adds them up. That's a total of 80 blocks. Now, the function checks if the amount you want is available. Say you ask for 2 blocks but only 1 block is left. It will let you know that there's not enough to take. If that is the case, the function prints a message and exits. But if there is enough, it removes the matching items from the chest. This clears out the stacks, preparing it to adjust what's left. Now the fun part, leftovers. If there's anything left after you take what you need, the function returns a leftover amount in chunks of 64. For example, if 80 blocks were available and you took 2, the 78 blocks left will be added back as 1 stack of 64 and a smaller stack of 14. Once the leftover stacks are added back, the function sorts the chest using bucket sort, probably sorting it by item type or quantity. Finally, it displays the updated chest grid so everything stays organized. So, to summarize, the take function in our Minecraft chest sorting algorithm searches for the item type that you want, checks if enough is available, removes what you take, adds back leftovers in neat stacks, and finally, sorts the chest to keep it looking spick and span. And that's how the take function keeps your Minecraft storage efficient and clutter-free. Whether you're hoarding birch blocks or sorting diamonds, this function's got your back.
Let's walk through what the combine unstack items function does step by step. This function is part of our Minecraft chest sorting algorithm. Its goal is to take unstacked or partially stacked items and organize them into a neatly combined sorted grid. First, it starts by aggregating all items based on their type. It uses a dictionary to collect the total amount for each item. By looping through the list of elements, each item and its quantity is added up, ensuring that the total amount for each item is combined together. Once the items are combined, the next task is to split them into stackable amounts, since in Minecraft, each item slot can only hold a maximum of 64 units. The function uses a loop to split the items into stacks of 64, leaving any remainder in smaller stacks. So if an item has, say, 150 units, it will become 2 stacks of 64 and 1 stack of 22. Next, the function sorts these stacks. It implements a sorting system using buckets, where each item is placed in a category based on its first letter. It then applies a custom sorting function to order these categories, followed by sorting the items within each category. Finally, after all the items are stacked and sorted, the function displays the organized chest grid, showing all the items in a neat, sorted layout. So, this function takes care of combining, stacking, and sorting your Minecraft chest content, making your inventory management way easier. Now let's take a look at the results of the different chest sorting algorithms we've applied in Minecraft. We've tested various methods, and together, these approaches significantly simplify the way we manage and organize items in chests. Each algorithm plays a unique role in making chest management more efficient. Quicksort and bucket sort allows us to rapidly organize large inventories, ensuring items are quickly sorted into their correct places. Linear search by letter helps us find specific items and organize them alphabetically, making it easier to access what we need. The add and take algorithms ensure that as new items are added or removed, the chest stays organized without manual intervention. Combined unstacked items help reduce clutter by merging partially filled stacks, making the most of available chest space. By using these algorithms together, we create a system that keeps our chest organized and clutter-free, making inventory management simpler and more intuitive.
Although this project is far from perfect, there are several things that can be improved if we were to spend more time on this in the future. So I'm going to talk about 4 of them. The most obvious upgrade would be implementing this into Minecraft with simultaneous sorting. Next would be adding the sorting option to items which stack in 16 or individually. Another idea is to improve on minor vulnerabilities like negative integer input handling. And finally, code shortening so that it doesn't take as long to run.